Okay, I'm going to finish up section 3.1 and 3.4 here. It says a rancher is fencing a rectangular area for cattle using a straight portion of a river as one side of a rectangle. The rancher has 1,800 feet of fencing and will not fence along the side of the river. What dimensions of the rectangle will produce the maximum area, and what is the maximum possible area? Okay, well, I've got 1,800 feet, so I'm going to let x be the width and y be the length of this rectangle that I'm building. Here's the river. X plus y is equal to 1,800, or 2x plus y equals 1,800. Okay, y is equal to negative 2x plus 1,800. Okay, if I solve for y, and a of x gives me the area of this rectangle, x times y, and of course I don't want x and y floating around. I'd like to have only x. I know what y is in terms of x. It's negative 2x plus 1,800. So negative 2x plus 1,800 times x gives me negative 2x squared plus 1,800x. Okay, and this is a parabola that's facing downward, indicated by the negative 2 there. And I need to find the maximum area. Maximum is a keyword here, and so I got to find the vertex. Negative b divided by 2a. 2 times negative 2 is negative 4. Negative 1,800 divided by negative 4, and then a of that is 450. A of 450 is 4,500. 40500. Okay, so I've got 405,000 is the maximum area. The dimensions are x equals 450 feet, y is negative 900 plus 1,800 is 900 feet. So probably how that rectangle looks there, where the width is supposed to be double the length is supposed to be double the width, and the maximum area that we want is 405,000 feet, square feet. Okay. Problem 13 and problem 14 are from section 3.4. So we're supposed to use the table to solve the inequality 2x squared minus 5x minus 12 greater than or equal to 0. Write your answer using set builder notation or interval notation. Okay, I'm going to start with, and all the terms are on one side already. If they weren't, I would need to get them onto the left. And I'm going to call the left side y and set y to be equal to 0. That factors nicely for us as 2x plus 3 times x minus 4 equals 0. 2x times x is 2x squared. Negative 8x plus 3x is negative 5x. 3 times negative 4 is negative 12 equals 0. So x equals negative 3 halves and x equals 4 are the two solutions. So my intervals that I want are negative infinity to negative 3 halves to 4, and 4 to infinity. Now I can choose any number I want in each one of these three groups. Just make sure that the number chosen is in the group. Okay, so I need a number, any number I want, less than negative 3 halves. Negative 2 works good. So if x is negative 2, then I got to find the corresponding value of y, and then I state whether that's positive or negative. Okay, so if x is negative 2 squared is 4, times 2 is 8, minus negative 10 is 18, minus 12 is 6. Okay, so 6 is a positive number. Okay, all right, positive for the conclusion there. A number between 3 halves and negative 3 halves and 4 is 0. 0 is a good number to use because we get y equals negative 12. That's a negative number for y. And then lastly, if I let x be 5, then 5 squared is 50 is 25 times 2 is 50, minus 25 is 25, minus 12 is 13. And 13 is a positive number. Okay. The next thing I'm going to do is I'm going to decide if I want the positives or the negative. Well, I've got an expression greater than or equal to 0. Numbers that are greater than or equal to 0 are positive numbers. Okay, so I want the two positive intervals to be represented. Negative infinity to negative 3 halves or 4 to infinity. Now the last thing I'm going to do is I'm going to take a second look back at the inequality there, and notice how that's a greater than or equal to sign, not just a strictly greater than sign, but an equal to sign, and therefore I'm going to include the values negative 3 halves and 4. If I did not have an equal sign, I would not do that. Okay, I would just have the answer what it is without the equal sign. Okay, so the set of all x such that x is less than or equal to 3 halves, anything less than negative 3 halves, or anything greater than 4 or equal to 4 is what I want. Okay, problem 14 is same deal. We're supposed to use a table to solve the inequality 8x squared plus 15x minus 2 less than 0. Write your answer using set builder notation or interval notation. Okay, so I got y equals 8x squared minus 15x minus 2 equals 0. Let's see here. So the factors of 2 are 1 and 2. That's easy enough. The factors of 8 are 1 and 8 or 4 and 2. Let's try 8 and 1. 8x minus 1 times x plus 2 should do it. And let me check that. 8x squared plus 16x minus x plus 15x, and then negative 1 times 2 is minus 2. So x equals 1/8 and x equals negative 2 are the two solutions that I want here. Above the table, I always graph these two numbers on the number line, and then my intervals: negative infinity to negative 2, negative 2 to 1/8, and then 1/8 to infinity. By the way, I'm not including the critical values. The critical values are these two numbers here. Okay. The reason why I'm not including those numbers is because if I'm including those numbers, meaning I got a bracket there, then I'm allowed to select the number, and that's going to return 0. Okay, 0 is not a positive or a negative number. Okay, so I only want to choose a number that is strictly less than or greater than the interval. The first number that's selected would be strictly less than negative 2. Negative 3 is good. So if x is negative 3, I get negative 3 squared is 9, times 8 is 72, plus 45, minus 2, 45 minus, 78 minus 45 is 33, minus Oh, whoops. 72 minus 45 is 27. Minus 2 is 25. Okay, that's a positive number there for us. If I use 0 next, if x is 0, then I get y is negative 2. That's negative. And then if I use 1 for x, I get 8 plus 15 is 23, minus 2 is 21, and 21 is a positive number. Okay, so now I'm going to look back at the original inequality and notice how I've got an expression that's less than 0. So I want the negative column represented. The negative column means I want the numbers that are between negative 2 and 1/8. I'm strictly less than 0, not less than or equal to, so I don't include the equal signs in my answer. Okay, the set of all x such that x is greater than negative 2 and less than 1/8 is the answer. Okay, so that's it for section 3.1 and 3.4 and what we've done here in chapter 3. So be sure to look at the homework problems for me when you get a chance, and that puts us done with chapter 3.